Hi, my name is Vincent, and today I want to take a look at evaluating limits algebraically. So we have evaluate the following limits, and for the first one we have the limit as x approaches 3 of 9 minus x squared over x minus 3. So we're going to break this down using the difference of two squares factoring technique. So we could rewrite our numerator as 3 plus x times 3 minus x over x minus 3. Now with this type of problem, it's important to know that we're going to cancel 3 minus x and x minus 3, but when we do, we have to replace one of the factors with a negative 1 because they're flipped. If we forget to put this negative 1, it's going to change our answer and we're going to get this wrong. So then we rewrite this now as the limit as x approaches 3, and we have negative 1 times 3 plus x. So at this stage here, we can evaluate this limit. Now all we have to do is just plug in x equals 3. So we have negative, parentheses, 3 plus 3. So it tells us our first limit is equal to negative 6. And just know, guys, for every limit problem, your first line of attack is to plug in the value x is approaching. But if we plug in 3 here, we're going to get 0 over 0, and that's why we have to do all this work. We have to do the algebra so that we could cancel a factor and then try plugging in again. So we go to the second example here, and we have the limit as x approaches 1/2, and when we look at this, 2x squared plus 9x minus 5 over 2x minus 1, you could spend a lot of time doing factoring by grouping or the AC method to break down the numerator, but with most of these problems here, the denominator will give you a clue that one of the factors is going to be 2x minus 1. Because for this limit to exist, this factor in the denominator has to cancel. So most of the time, this will help us predict what one of the factors is going to be. So we would have 2x times blank is 2x squared. Well, that would be 2x times x. And then we think negative 1 times blank is negative 5. That would have to be positive 5. And if we check this out, 2x times x is 2x squared. We'd have plus 10x minus 1x, which would give us the 9x in the middle, and then negative 1 times 5 is negative 5, so it checks out. Now we could cancel out the common factor, 2x minus 1, and now this is the limit as x approaches 1/2 of x plus 5, and now that this is simplified, we could just plug in. This is equal to 1/2 plus 5, so our limit is equal to 5.5, but we probably want to write this as an improper fraction. This is also equal to 11/2. So our answer to the second example, the limit as x approaches 1/2 of our function here is 11 over 2. Okay, well this is going to conclude this video on evaluating limits algebraically. Thank you all for watching, and I hope that this was helpful.